Hey folks, Mr. Dell here. Hey, we are looking at solving equations. So we have, I'm using some examples from CPM. This is from CPM, and this is course 3, and it is specifically number 561, which comes from section 5.2.4. Okay, so number 61. And it's a checkpoint exercise for us. So that means it's time to really make sure we know how to do this and some extra practice. So I'm going to go through each of these and really make sure you know the process in solving equations, right? So solve each equation, right? We know that solve each equation. What does that mean? I want to know what value of x, in this case, those are all have x in it. What value of x makes the equation true? That's really what I'm looking for. I mean, I could sit here and start guessing x's until I get the same thing on both sides, right? So 3 times some number plus 7 equals negative that number minus 1. So I can play around with the numbers until I get it. But a lot of times, if our number is a fractional value or a negative integer, it maybe be difficult to do this guess and check process. So there's a process of solving. So we're going to go through that process here. So that solving process, I'm going to rewrite. There's some few steps. One of the steps, the first step would be to simplify, is what we have. Simplify each side, right? Each side independently. Simplify each side of the equation. So here's of the equal sign. So here's the equal sign. So I have two sides, a left and a right. And if I look at both of these sides, they are completely simplified. There's no combining alike terms to do. So that means I can go on to the next step. Next step would be to get x only on one side. So to isolate the variable term would be the official verbiage here. Isolate the variable term. That means make the x only on one side, the x term on one side, because our goal, remember, is to get x all alone. We want to know what x is. We do inverse operations to get x alone. So if I want to isolate the variable term, I have a 3x is one of the variable terms, a negative x is the other variable term. So I need to just remove it from one of the sides. So I'm going to remove it from this side by adding x, right? Because it's a negative x and a positive x. What happens is it's removed. And then to make this a legal process here with an equation, what I do to one side, I do to the other. So I'm also going to add x to this side. So now I have 3x plus x, and remember that x is a 1x. When you have just no coefficient in front, that coefficient is always a 1. So 3x and 1x makes that 4x plus 7 is equal to, what's left over here is this minus 1, which becomes a negative 1. Okay, and then after isolating the variable term, actually, I'm still not done. I've got to isolate the variable term. I can look at it also as isolate the constant terms, right? So isolate the constant. So that means get all the numbers on one side and just the variable term on the other. So I'm gonna instead of plus 7 here, I'm gonna subtract 7 from both sides, because that'll eliminate that 7 from this side, and it gets my variable term now completely alone, 4x, the term itself. And over here now my constant term is going to be isolated because I have a negative 1 and negative 7 make negative 8. And then the last step normally here is to divide by the coefficient. Right? Remember coefficient. What does coefficient mean? Coefficient is the number that's being multiplied to the variable. In this case, it's 4 times x. So I'm going to divide by 4 both sides. And so I have negative 8 divided by 4 is negative 2. So there's my final answer. And again, if you wanted to check your answer, what do? You put it in place in the original equation and make sure it did work, right? If I put a negative 2 in here, I'd have 3 times negative 2 plus 7. And then I need to know, does that equal negative 2 minus 1, right? So negative 2 into the x So this becomes negative 6 plus 7, which is 1. And this becomes a positive 2 minus 1, which is 1. So yes, it checks out. So you plug it back in to see if it checks. All right, let's look at B. I'm going to go a little quicker here. I had to do some explaining, so we're going to do B. So B, the equation is 1 minus 2x plus 5 equals 4x minus 3, right? Remember our steps. First step, simplify each side. So I look at the left and the right side of my equal sign of my equation. So if I look at the left side here, what do I notice? I actually have some combining of like terms I can do. I have the term of 1, a constant term of 1, and a constant term of 5. And this is a positive 1 and a positive 5, make it a positive 6. So I have 6 minus 2x equals, and then 4x minus 3. There's no simplifying to be done there. So first step done. Second step, isolate the variable term. So I'm going to get all my variable terms on one side. So I tend to lean to having my x over here, my x on this side, my x term. So I'm going to subtract 4x. That eliminates it there. So subtract it here as well. So now I have 6. Well, first of all, I have a negative 2x and a negative 4x. Negative 2 and negative 4 make it negative 6. So it's 6 minus 6x equals, and then now I am left with a negative 3 on this side. So then the next step, isolate the constants. So I have a positive 6 over here. To get rid of it, subtract 6. Do a negative 6. So put a negative 6 with that positive 6. It cancels. So now I have negative 6x is equal to negative 3 and negative 6 make negative 9. So last is this divide by the coefficient. So I divide by negative 6, right? And I didn't leave myself enough room. So I'm going to divide by negative 6 on both of these. So that leaves me my x is equal to, so negative 9 divided by negative 6. Well, 9 doesn't divide evenly by 6, but I can simplify that as a fraction. First of all, negative over negative is going to make it positive. And then 9 over 6 can be actually divided by a giant one of 3 over 3, which gives me 3 over 2. So that's my final answer. X equals 3 over 2. Okay, there's B. All right, let's do C. C is negative 2x minus 6. Oops, can't see that, can you? Here we go. Let me just write it, and you'll be able to see what I write. So negative 2x minus 6 is equal to 2 minus 4x minus the quantity x minus 1. Okay. So once again, if I look at my left and right side, left side, no combining like terms. Right side, definitely some simplifying to be done there, right? So this is 2 minus 4x, and then here's the key. That minus is in front of a set of parentheses. So what that means is I have to distribute this to each of these terms first before I can combine like terms. So this becomes a minus x, and then it becomes a plus 1 because the minus becomes positive 1. And then I can still combine like terms. Here I have a negative 4x and a negative x makes that a negative 5x. And then a 2, positive 2, and a positive 1 makes it plus 3. So now I've simplified this side, and now I can go ahead and do the next step. So the first step was simplify each side. Now isolate the variable term. So that means eliminate it from one side. So if it's a negative 5, I'm going to add 5x. And I do it to one side, do it to the other. So I have 3x minus 6 is equal to what's left over here, just the 3. Isolate the constant term, step 3. Add 6, add 6. So we end up with 3x is equal to 9, right? And then last step, divide by the coefficient. The coefficient is 3, divide both sides by 3. Final x equals 3. All right, last one, D. D is, let's see what I'm writing here. D is 3x minus 4 plus 1 equals negative 2x minus 5 plus 5x. Okay, So here's D, and again, left and right side, I definitely have some simplifying on both sides this time. So first step is simplify each side, right? And I have some simplifying to do on both sides. So this left side here, I have a -4, my constant terms, a -4 and a +1, make that a -3. So it's 3x minus 3. Now that's simplified. Over here on this side, I have two x terms. One's a -2, one's a +5. So that becomes a +3x. And I still have this -5. Okay. Then the next, isolate the variable term. That means eliminate it from one side. So I'm going to subtract it from here. And the -3x eliminates it there. And then I subtract it from here as well. Now, if I go in and look and to see what's going to happen here, actually my x terms cancel in both sides. So this is a situation where now I look to see what's left over. I have a -3 is equal to -5, and that is not true. So what that tells me is if I look back up here, I was asking you to take 3 times some number, subtract 5. When will it be 3 times that exact same number minus 5? Subtract 3, then minus 5. It'll never be, you'll never have a number that will work for this. And this is also proof of that. At the end, if we end up with a false statement, then we really, at this point, just say X has no solution. Okay, X has no solution. There's no number that will work for this equation to make it true. Okay, all right, there you go.